Welcome back, everyone. If you're a focused learner looking to crack the code of basic electronics, without getting bogged down in all that dense, confusing jargon, well, you are in the exact right place. Today's explainer is all about demystifying one of the absolute most essential rules of electricity, and we're going to do it by breaking down some really fantastic concepts. We're anchoring this explainer with foundational material from AI Tech Hub. It's really the perfect starting point to just cut through the noise, skip the fluff, and get right to the core of how all this actually works. Because, let's be real, the biggest hurdle we face when learning about electronics is that electricity is, well, it's invisible. We literally cannot see electrons moving through a wire, and because of that, the whole concept can feel incredibly abstract, maybe even a little intimidating. So, how on earth do we measure or even just intuitively understand something we can't physically see?
Think about that classic standard electrical circuit you've probably seen 100 times in textbooks. You've got your power source, the battery, on one side. Then you have your output, the light bulb. And those directional arrows, they show us the flow of electrons traveling through the wire to actually make that bulb light up. It's clean, it's scientific, sure, but it's still kind of abstract, right? Enter Ohm's law. This is the ultimate scientific solution that unlocks that whole abstract concept. Ohm's law defines the fundamental mathematical and physical relationship between three absolutely crucial things: voltage, current, and resistance. It's literally the formula that allows us to understand, predict, and accurately measure those invisible forces flowing through the circuit. So, let's map these formal variables directly to a physical circuit to make things a whole lot clearer. Resistance, represented by the letter R, is our light bulb. Current, represented by I, is that flow of electrons moving through the wire. And voltage, represented by V, is our battery. Boom! Suddenly, all that intimidating math has a physical, real-world location. But, simply knowing what the parts are doesn't fully explain how they work together. The really crucial question is, what is actually happening inside the wire? How do these three distinct forces, the battery, the flow, and the bulb, physically interact with each other in real time? Like, if we could shrink down and hang out inside that copper wire, what would the dynamic actually feel like? Well, there is a brilliant visual metaphor that totally answers that. This is where those dry, dusty technical terms suddenly spring to life. We're introduced to three distinct animated personalities: volt, amp, and ohm. Honestly, this changes everything. Instead of just lines and arrows on a page, we now have a tangible physical struggle that completely demystifies the physics. To make this super easy to digest, just watch how the textbook science maps perfectly to this vivid little scene. The battery, providing the voltage, is our character volts, and he is actively pushing. The flow of electrons, our current, is amp, who's the guy physically trying to move through the space. And the bulb, providing the resistance, is ohm, standing up at the top, literally pulling on a rope to tighten the pathway. Watch how this builds into an awesome active struggle. First, you've got Volt in the back really putting his back into it, shoving incredibly hard to generate forward momentum. Second, Amp is caught right in the middle, desperately attempting to squeeze his way through that narrowed path. And finally, and notice how he's deliberately dragging it out, Ohm is sitting up top, mischievously tightening that rope right around the pathway, deliberately restricting Amp's flow. Just look closely at the dynamic between Volt and Amp for a second. Check out Amp's face. He looks completely strained and exhausted. It becomes instantly clear that without Volt doing all that heavy pushing from behind, Amp would have absolutely no momentum whatsoever. Voltage is literally the pressure that forces the current to move. No push from Volt, no flow from Amp. It's that simple. And then there's Ohm. Notice the literal horns and that devilish look on his face. He acts as the bulb in our circuit, and he demonstrates exactly why we use the word resistance. He is physically choking off Amp's path. He definitely doesn't want Amp to get through easily. And here's the kicker. When the current has to fight through that restriction, that intense effort is exactly what generates the energy to light up the bulb. So when you step back and view the complete picture, you realize something pretty amazing. The highly technical, kind of dry textbook diagram and the highly intuitive comedic cartoon are telling the exact same perfect story. The battery pushes, the current flows, and the bulb resists. It takes the invisible, abstract nature of electricity and turns it into something you can practically feel in your own hands. As we wrap up today's explainer, I want to leave you with one final, kind of provocative thought experiment. If Ohm pulled that rope tight enough to completely close the path and stop Amp dead in his tracks, what would happen to volts push? Think about that physical relationship the next time you're wiring a light or tinkering with your own DIY electronics projects. Keep this little character metaphor in your mind, and I promise you, the invisible world of electricity will never confuse you again. Thanks so much for joining me, and keep learning.